Good morning, sir.
There's so many students missing now still. We have 34, 32. There should be 40 something. Do they know that we have a quiz today at 8 o'clock? No one's sure about that. So, okay. Okay, then. I should close this thing. And then so you will have a short quiz at 8 o'clock about 2 questions, and then you're supposed to answer by yourself. Because this typical question that I ask in the quiz is not kind of you can find in the internet. It's kind of your thinking. It's easy, so I can see easily whether it is copied or not. So please be care about that because it's impacted to your score at the end. And today we will shortly give you some introduction about the non-destructive testing. But I believe that it should be given is as also laboratory work. So then I little bit go through it, not really detail on it because you have a practicum on it. Just principle behind the non-destructive testing, why we do need it, and how useful this information for engineering application. So I'm using my computer. It's not using a tab, but I say easily that that we understand in material science. We are working a lot with the microstructure and with designing component. Okay, and during the process like casting, welding, or any other process, we are tend to have it kind of defect on it, and then that's why we need to have, we call it a testing. But we have learned from Metal 1 and also some part of Metal 2 that tests can be done destructive, which means that you cut the components and you make a sample from it, and then you test it in a machine. For example, if you're doing a tensile test, which means we call this kind of test as destructive testing, and it is in the component scale. So it is in the component here, and then but also it is not always the case, which means that you cannot cut the sample or the component, and then you should do it as a non-destructive testing. So non-destructive, it means you not destroy the sample or destroy the component. It's also important this kind of testing for qualification or assurance that your product is actually follow the standard or fulfill some kind of standard. Therefore, you need to test them. And this kind of test, you do it without destructing the samples. That's why we call it non-destructive testing. So there is also a possibility for assessment. So you know that if you have a kind of component, for example, running already for 10 years, and then you need to know whether it is already some flow in it, or in a better question, whether your equipment is safely operated in the next future, or how safe your component in the coming time. Which means, for example, if there is a question for further 10 years, is it safe or not to run this kind of equipment? So this kind of question can be answered when you know the state of the equipment, when you know that your equipment is free from defect, or if it is defect, and then you can calculate how far it can go. So this is the way to do it with we call it non-destructive testing. So you find a crack, as you remember from the metal one, that you find a crack and calculate how much it goes. So if you remember from the fatigue, if you have initial crack, then the crack can grow, and you can calculate how long it goes until it is give a very critical length of crack. So this is because this kind of crack, we call it a crific crack, can give you some concentration on the stress concentration. So it's also the same illustration basically, and this is also the third is that you would like to know um, if you you have found a failure in some component, you know what is the reason of that, or we call it root cause analysis or failure analysis. You know that you need field investigation, second part of this. So you have the step involving at least 4 steps, and the second step it is involving, we call it non-destructive testing here. So in destructive testing is basically a part of failure investigation. You need to do this thing, to do the failure investigation, and then of course you need to have the non-destructive testing to do failure analysis. So I will try to look for the pointer, but I cannot find it. So, see. Okay, no problem. So it's just some picture about people doing NDT tests. But let's dive into it. So we will do short introduction to the non-destructive testing, and then overview of 6 common method. It's common. That's something that we already apply or used to use it, and then some selected application if the time is allowed. We should stop at 8 o'clock. And what they call NDT, of course, that's from the word is that this is non-invasive technique. So it means that you're not doing distraction on the sample, and it's not change the integrity. The integrity of the material. It's not change the integrity. It's also of material. It's not change the microstructure. It's not change the component. It's not change on the structure, or it can be also as quantitatively measure some characteristic of object. It's more common broad definition, but in short, we call it inspect or measure without doing any harm to the component. And then this is there are a lot of NDT technique today. There are many things, and one of them we call it a visual inspection. Basically, you are using a eye or any tool that is still not really a delicate tool. It just, for example, using a loop or any camera, macro camera, and then you do it. We call it this thing, call it visual. And then also there are common method today. We use ultrasonic method. Here, ultrasonic is below here. I'm not sure that you can see the pointer. You see the ultrasonic, and then you also, we call it X-ray and then later on we will discuss what is difference or how they use. It's basically all the electromagnetic wave with the different length of the wave, the different wavelength. And then magnetic particle, basically this are other difference compared to the X-ray and ultrasonic. And then this magnetic particle, you are using magnetic polarization. You know that magnetic can be polarized into south and east, and you use it for testing something in the ferromagnetic stuff or ferromagnetic material. And then liquid penetrant is also not really complicated, and we have also we call replication, and then we have the eddy current. Basically, eddy current is the same thing as it's not the same. It's close to magnetic particle. Then the application also quite close to each other. It's not a big difference. Basically, to detect any crack. Um, what example using the NDT example flow detection. So if you have production and then try to evaluate if there is any crack, and also leak detection, and also locate the crack. Sometimes it's also used to measure the dimension if there is any change on the dimension of your component. And then another case, you can use it for structure or microstructure when it is changed on the microstructure because of application. For example, when you weld something and then you apply for a long time at the high temperature, then some microstructure will change, and you can do NDT basically to measure if there is any change on the microstructure. And then also to estimate hardness, sometimes you can measure, for example, when you learn about the hardness measurement, what you are thinking is that you cut the sample and you bring it to the lab and you're measuring it. But of course, there are also other methods that classified as NDT, basically to measure the hardness. Of course, there are also possibility to measure the stress, also measuring the chemical composition of the component. So basically, this is typical application of the what you call non-destructive testing. Yeah, it is just highlight what I mentioned in the beginning. It is useful for product development, for failure analysis. This is inspection in service gimmick or verify that you already do proper assembly or proper processing of the system. So basically, I just repeat myself. Okay, and then so this is a 6 common. Basically, with one addition, right? So not 6, basically 7. So one visual, liquid penetration, magnetic, ultrasonic, eddy current, X-ray, and then this one is in situ. I add myself this technique. Basically, it is the 7 technique basically, but the 6 common is here. Okay. So visual instruction basically using anything, yeah, in addition of the human eye. You can see it with yourself. Example, if we are talking about inspection, and then you see it with your eye if there is no defect. Okay, and then this is kind of non-destructive testing. We are not the disrupt any component, so using the eye. But there are now there are a lot of tools. You do it using, for example, fibroscope or boroscope here. It is kind of optical technique. It's kind of microscope. Then you see it with fiber optic. So you bring the camera inside the system, and then this time you are using, for example, if you would like to know what the condition of your steam turbine or your aerospace turbine when you do it aerospace investigation. You see there are gas engine that you should look inside, and it's very costly if you should open it. So it's not possible to open it because of the timing or because the cost. And then what you do is that you insert boroscopes, this kind of fiber optics things with the camera head, and then you do the inspection. You will see that if there is any dents or any things, then it can be visible in. And then it's also yeah, it's also I can give a quick practical application on it because you just recently have it. Let's see it if I had. You see my um, uh, you see my slide, not slide, the PDF file. This is from PKT, Pupuk Kaltim. You see it? Or yeah,
Yes, sir.
yeah. You see, this is basically equipment. We call it the heat exchanger equipment, where you exchange a heat, basically heat coming from the combustion of natural gases, and you need a steam in the process. It is ammonia. Basically, making ammonia, as you remember from MIT gas lecture, I don't know you or other person that doing that. Basically, ammonia can be made from a reaction of nitrogen with hydrogen, and then doing so, which means you need water because you need hydrogen from it. So what is should be done is that you make a steam from the uh, from the from the water, and you should heat it using natural gas combustion. And then this kind of heat exchanger, you already learned it from thermodynamic or perpan, how to design such equipment. Basically, you need to calculate the amount of the surface you needed to calculate how much steam you need for the process. And then to doing so, you should do some kind of arrangement like this tubing, and then this process, people are inspecting whether there is any defect on the tube from the internal. So it's not possible to do it easily when it is in the internal, right? So what we do is that you use a kind of a boroscope, you insert it inside it. It's not visible now, but you insert from one of the tube somewhere here. I'm not sure if you can see my pointer here because I cannot see. You can see my pointer, right? This thing. I cannot write here, so let's try to make a note. No, it's not possible to do that. So okay, anyway, you see on the left side, this is number. So left here, you see that photo number 5. This is kind of inside the internal tube. See, it is from the boroscope. You see the here, we got a boroscope sizing. So which means that using this NDT technique, this is kind of visual still, but you are using boroscope, which means that you insert the stool inside the tube, and you see it with the camera. You see that there is any groove here. So which means that inside the tube there will on the photo number 6 here, you see that there is kind of dense. It's kind of visible when you cut it. So before you cut it, you should do it this, because you don't know the location. So when you already knows the location, and then you actually cut the tube and observe this kind of defect here inside. So this is because of the process. So at the end, the stories that you would like to know what is the reason, and you do what we call root cause analysis. To in the end, you need to redesign them, whether it is problem of material or problem of operation or any other problem that coming up in the system. So basically, how this is application in the real world industry that you will apply about this non-destructive testing. Yeah, any other question or any question coming up? So this is understand, yeah, this is not really difficult, but it is a real application of what we call visual inspection. This is kind of visual inspection. Okay. Okay. So this kind of borescope, there you see already there are a real application of it, and then we also have liquid penetrants. There are also some application that I have in my project, but I will not show it because the file is still somewhere. Basically, the things that you have a crack, and the crack is basically on the surface. So liquid penetrant is only work if you have if you think that the crack is or are on the surface. So because what is done is basically chemical things. So you expect that the liquid, we call it penetrants, is absorbed by a crack using capillary. So which means that liquid with high surface wetting, which means that you try to find a chemical, and people sell this kind of chemical. You can find it in the store. Chemical, you just buy. I buy liquid penetrant. The cost is about 300,000 rupiah atau 300,000. You expect that you get this liquid penetrant, and you coating, or not coating. You wet the surface, uh, wet the surface with this liquid penetrants, and then there are two ways to do it. So first of all, you should put a wetting liquid first, and then this liquid is applied on the surface that you think it is contain a crack, and then we have to clean it again to remove the excess liquid, which is something on the surface, but on the crack is still remaining. It's number 2 here. So uh, all the liquid is clean from the surface, but not that on the crack. But it's not possible to clean it, of course, because we set it up so that the penetrant is infiltrate the crack. It's number 2. And we call it developer, which means you give a color on it. So sometimes this liquid is doesn't have any color, or not non colorful. So what we do is we call it a developer, number 3. It's kind of powder. It's applied to pull the trap penetrant out of defect, so it will visible with your bare eye. So the number 4 that developing agent is split on the surface, and then I will be refilled the color. So basically something like that. You see, there will be something like refill the color, or you can also add the developer as a fluorescent, and then if you make a light, then they will visible as a crack on the surface. It is something that maybe there's also some application on it. So application is of course fatigue crack. You remember that fatigue cracks, any cracks, seam, lap, porosity, overload, impact fracture, pinhole in weld, lack of fusion, any any other crack in the process, you can detect using this kind of penetrant test. So I will not say this is just you can read it. So the third method, we call it magnetic particle. Basically, what we do is that you have a powder that is magnetized. You know, it's kind of iron oxide. If you play in your childhood, you have magnet and you throw it in the sand or in the ground in front of your home or your house. You'll see that there is a black powder actually um, accumulated in the magnet, right? This is because of the magnetic properties of the iron oxide, and it should look black, right? They are oriented somehow in the direction south north pole. So they are oriented basically. So when we apply a powder on the surface, you see, like that, with its magnetic particles, with this particle that's magnetized, for example, iron oxide, and you apply a magnetic field using yeah, any other equipment. You can use it any other tool to develop magnetic field on the component, and you see that the there will be some disruption on the magnetic particle, and then it will visible as a crack, like you see on the right side, because there is a change, disruption on the magnetic flow from south to the north. So basically, that's the things. Well, you're probably asking why just not using liquid? Is this no? Because liquid only work for defect that is open, so which means that on the surface. While there are also some defect, it's not it's not open, so it's closed. It's a little bit under the surface. It's not visible, so there is not possible for the liquid to go in, which means that that's not possible to do liquid. So that's why magnetic have their advantage on this situation. So this is the tail on it. So you have a crack here, for example, that is a crack indication, and you have powder basically on the surface of the equipment, and you apply this magnetic field using the electrical, of course, and then you see that there is a disruption on the crack. So the orientation of the magnet will be somehow uh, new pool will form when it is continuous. So you have south and east, of course, something like this is a south and north to south. But when you have a crack, then a new pool, north south pool, will be formed. Therefore, something like that. So there will be see as a crack visible on it. So that's basically. So this is an example. When you don't see it with your eye or you don't see it with liquid penetrant, you can do it with magnetic. Sometimes the magnet particle can be colorful because they are given a color on it, so it's easily visible with kind of tool or just with bare eye. So that's magnetic particle. Basically, this is radiography. Well, it's like in X-ray. You need the X-ray generator. It's basically uh, in the hospital when you try to look inside your body, and then you if there is any broken bone or thing like that, and then you need X-ray. This is the same exactly things, but just different in the energy. You will not use this tool for your body because the energy is different. Mean that the amount of energy or the voltage of the system is different. So in the hospital is quite low energy density. Is not destroy part of your cell. And for engineering, because we needed to do it in the for metals, so you need a high energy. So this is, for example, if you have defect in the inside. So this is for defect that's inside. It's not on the surface or little bit below the surface, or called subsurface, but it's just inside it. For example, if you have welding, if you have weld something and then there is content porosity inside the welding, and then you can do it with X-ray system. So basically, we have also some example on it. Um, so this is with X-ray. Uses film radiography, and you need be trained very well to do this. It's kind of an expensive NDT method. Yeah, there are also other application in casting, in electronic production, in battery, and anything. Basically, there are a lot of now going on, and now it's not only 2 dimension; it's become 3 dimension. And then also sometimes you can record a video. So basically now the technology is actually improved very well, very much. And then the third, sorry, so probably the last, we call it eddy current testing. So basically what you do is that you not applied any magnetic field, just applied um, uh, um, kind of electric field to generate eddy current field. You can look into Wikipedia what is eddy current is. Basically, the current that is induced by application uh, of uh, of magnetic field. So if you apply magnetic, of course, it's kind of, you see that magnetic and electric is somehow is two things. Then you can induce each other. You can generate magnetic field from electric. You can generate electric from magnetic, as you remember from your physics class. So basically, this is happening when you have a crack. Then there will be a formation of eddy current of it, and then this is a quite simple method. That's why it is applied. You need some kind of a proof like that, and then you should detect the eddy current basically. And then this is used very much for inspection of small equipment, for example, during this qualification of casting product here, as the example here. Okay. Yeah, this is the last, I think, the ultrasonic method. Basically, not using any electricity or any magnetic, just using uh, ultrasonic wave. So you know that ultrasonic wave have some special range, wavelength range, and then basically it's kind of radar technique. You see that you will have the lab on it. You have a kind of reader here, and we call it oscilloscope, just to give any ultrasonic wave, and then catch up the wave after it. So which means that you have a generator, and you have sensor to catch the back the ultrasonic wave that is come back from the sample. So here, for example, here, if you have the ultrasonic wave, you see like that. If there is no crack, and then you see that the bouncing echo will be far away from the initial pulse here in this peak. So this is about 5 here. So it is above 5. There will be no crack here. But if you find a crack between this sample on this crack, you see that it is shorter distance for the wave to come back. So which means that you will be see a peak between this. So this is the crack. So it means that you can quantify the crack, which means you can know how long is the crack, how deep is the crack. So this is the advantage of ultrasonic. Not only knows whether it is a crack or not, but also to quantify them. So you see the difference between the liquid penetrant sample compared to this technique. It is give you advantage that you can locate the crack and also measure how deep it is from the surface. So, well, there is another technique for this ultrasonic. There are a lot of technique, and you can get certified with this. But basically, it is fundamentalist, not difficult to see. It just playing around with the equipment, and then you can also do imaging with that. See, if you have any light, any wave, you can image something, right? Of course. So I think that's all. Uh, this is just application of it. I will post it this into a classroom. You should prepare for the quiz. I think they'll come out at 8 o'clock. You can check. I give you a lot of time. It is half an hour, and then 5 minutes to submit it. If you have any other process submit. So the quiz will be open at 8 o'clock, and it will be closed at 8:30. And you cannot work again. I mean, I think the screen will be free somehow. You cannot write anything after 8:30. So be aware that 8:30 everything will be closed. But you can submit that after 8:30 until 8:35. We call it a grace time. You see, in the classroom they call it grace period, or the time that you can submit the quiz. So there will be no other excuse for them that's not submitted on time. So this time because it's very difficult to accept with email, and there is other things that sometimes double submission, some people is. So please be prepared. Please use a computer instead of your yeah, you can use a tab, of course, but I'm not sure if you can use your phone or HP or thing like that. It's difficult. Sometimes it's not compatible with things. So please use your PC or computer to work on the quiz. And then the quiz will be, as I said, it will be closed at 8:30. So at 8:30 you cannot work anymore. So but you can submit it 5 minutes 8:30 to 8:35. So there will be no. I think it will be, yeah, someone that have a problem with the devices or computer network and things like that can inform me now, so that I can anticipate it who will be have a problem with that. So there are now some participant is not here. I'm not. Yeah, I'm not sure. Yeah, I'm not sure why. There are some person is not coming out yet. You can tell them. I mean, the class coordinator. I'm not sure if we have one. We have a class coordinator. Please inform them that we have a quiz at 8 o'clock, as I mentioned last week. So just a very quick question, and it's not that difficult, right? Any question concerning the lecture, also the quiz?
Maybe not, sir.
Okay, have you tried to open a classroom and you see that you'll start at 8 o'clock, right?
Right, sir.
Yeah, okay, good. Okay, but I closed the Zoom, so you are not disturbing with the Zoom. Next time we have yeah, kind of a Zoom process in the final examination, but not today. The quiz is free. Just so I will close the Zoom, and then if you have any question, please post it in the group. I will be happy to answer that. So thanks everyone. Good luck for the quiz. See you again next time. Bye. Assalamualaikum.